Good evening, sir. So, moving on to the sixth session of our faculty development program, it is our privilege to welcome Professor Abdus Professor and Head of the Department of Ocean Engineering at IIT Madras. Professor Samad is an internationally renowned researcher in ocean energy systems, design optimization, and artificial intelligence applications in engineering. With over 170 Scopus Index publications, multiple books with Springer, and 5 patents to his credit, his contributions to the advancement of ocean engineering are both prolific and impactful. He has been recognized with several prestigious honors, including the Institution of Engineers Award, and has built strong research collaborations with leading institutions across UK, USA, Germany, Korea, and Japan. Beyond research, Professor Samath is an active academic leader who has organized numerous international workshops and conferences, bringing together researchers, industry experts, and policymakers to advance sustainable ocean energy solutions. Today, he will deliver a lecture on harnessing ocean wave energy, flow rectifications, offering valuable insights into innovative approaches for utilizing marine resources to meet future energy demands. Let us warmly welcome Professor Abdul Samad.
Thank you, Shafak. Uh,
Thank
yeah, thank you for this introduction. Uh, yeah, I am working here in ID Madras last 15 years, and basically I'm working on marine energy, wave and tidal energy. So we have done lots of work on, especially on wave energy. So that wave energy basically in IoT. If you see the story of ocean wave energy, it started about 1980s. The National Institute of Ocean Technology in Chennai. This is Ministry of Earth Sciences Laboratory. They created one research center or research laboratory in Chennai called MOES. So they developed some wave energy converter. I developed turbine for them. Then I'm developing my own wave energy converter. So that way I'm linked with wave energy actually. Basically, my all students are also involved in wave energy system development, different aspects of wave energy. So I'll try to show something. Let's see. So I don't know. Okay. So my basic presentation will start with basic renewable energy, then marine energy, then wave energy, then actual topic I'll go oscillating water column. But if I do not explain the basic part, then actually you will not understand from where I'm starting. Okay. So whenever you are developing any technology, let's say any technology, any AI-based technology or any core mechanical electrical systems design, so you have to pass through several technology readiness level. So whenever you are working on a basic part, let's say you have one concept, you publish one or two paper, and you did some numerical modeling, no laboratory work done. So there will be technology readiness level or TRL one or two. Okay, then you do some more work and do some experiment in laboratory. Then it will be like technology readiness level three. Okay, so within three you are there. Now, if you want to move technology readiness level 9, 9 means actually system test launch. Uh, just please wait 1 minute. So, technology readiness level 9 means actually it has gone to ocean or field where you are applying commercialization happen. So technology 1 to technology 9 you have to reach gradually one by one. So 1 means you got some idea, 1 or 2, and 3, 4 means laboratory system you have done. 5, 6 means you have done some field trial, and 7, 8, 9 means actually you are nearby commercialization. So you've prototype demonstration you have done up to 6. Then after that, some company or industry has been taken over your idea, and you are going for business or commercial. Yeah, so normally our academic institution will be working the TRL low, like TRL 1, 2, 3 within that range because we publish papers, we do some numerical modeling, but sometimes we may have laboratory or may not have. If don't have laboratory, let's say many smaller colleges, they may not have laboratory, but they have good numerical analysis, so they may not able to reach up to 4 or 5 or something. So in that case, they will stop their work only through publication. And some research laboratories, such as CSI laboratories, NCL, CLRI, and many laboratories, CMARI. So those laboratories, they can push technology to 4, 5, 6. Then some company will be coming up, and 7, 8, 9. Those part will be happening. So our academic institution, we have limitation because we have teaching responsibility, and we generate idea, and we publish some papers, then we forget about our idea, because pushing towards 9 is very difficult. Okay, then if idea is good, so one more thing. So when you are generating idea, idea generation, if you are generating say 100, then coming to 4, 5, your majority idea will be uh, wasted, or it will not be working. Okay, so when you are reaching to 4, about 4, then actually only few ideas filtered which are not workable or not possible. Then you reach 4, 5, 6, then many again ideas will go, because you will not get funding body who will be funding you, or company will or government agency will not support you. So only few will be surviving. So among those few survival, again you are trying towards commercialization. So again further down will be there. So finally, if you are generating 100 idea, maybe one or two will be reaching to 8, 9. Okay. And it is true for all over world. Okay. So initial part, lower part, number of idea generation will be huge. Then when you're reaching 9, so only one or two will be surviving. So percentage of survival will be very low. Okay. But within that ecosystem also, we have to survive. We have to generate idea. So some idea will be taken over. Okay. If you do not generate idea, then anyway, it is not going to reach anyhow. But if you generate many ideas, maybe some will be taken over. So whenever you are in different engineering colleges or wherever you are, you generate idea and try to push your technology for higher technology readiness level or higher TRL. Okay. Now here I have given one picture. They call Darwinian Sea. So research and innovation academic institution will do publication some paper. Then if you see the central portion, some water is there, fish is there. It's called Darwinian Sea. So many ideas will be crashed or dead here. Okay, because you will not get funding body, you will not get testing setup. For example, marine energy system, you need large testing setup. So you generate many ideas, but you will not get the testing setup. So finally, your idea will get zero. Okay. Then few will be crossing this Darwinian Sea, and they will see the world, and they will make beautiful future. Okay. So this way the technology moves from TRL or technology readiness 1 to technology readiness level 9. And technology readiness level 6, 7 does not come in one day. You need lots of research, lots of effort. You have to cross 3, 4. Then you are reaching to 7, 8, 9. Okay. So once you reach 6, that means you are very much successful. Now commercialization, if they are taking, okay, not taking, still fine, because technology got somehow some sort of maturity. Right? But if something is in paper, so that may not be having a proper commercialization plan. Okay. So many time, many college faculty or student, they'll come to me and they'll say, so this is the idea. I say, can you do some numerical analysis? Someone will be doing some numericals. Can I, then I'll ask them, can you do some experimental modeling? They will do some, and many will not do because financial constraint, another constraint will be there. So their idea will get died there, but only few can cross. Okay. So whenever you're reaching technology readiness level, so it takes time. Okay, many technology can be quickly moving forward towards 9. Many technology will take years to reach towards 9. So now, okay, invention on it define renewable energy. Already you are renewable energy forum, and you have seen the several types of renewable systems are there. One is marine, another is solar, wind, biomass, and small hydro. So these sort of basic numeric your renewable energy system. There will be some geothermal also. Uh, Now, I'll not discuss everything because you may have heard already solar wind is very much popular in India because solar sunlight very strong in India. So people are using solar panel at their home, their offices, their agriculture field, and Ministry of Renewable Energy also they have solar helpline. They're assisting. And wind energy also government is funding lots of money to develop wind energy, and offshore wind energy also they're trying to fund. So the technology is getting pushed, and those technologies are actually almost mature, because wind solar system already all over the world people are using, so it is mature technology. Wind turbine also mature technology. But whatever I will be discussing, that may not be so much mature, because that needs lots of effort, lots of thing to make it mature. Okay, so India's electricity production, you can see, like, we are top consumer actually, production and consumption both way. China is consuming more, and many time we define countries' development based on their electricity consumption. So China is consuming more, means they are more developed than actually India. But anyway, number of population also matters. But per capita power consumption, if some country is having higher, that means those countries will be underdeveloping or developed or underdeveloped condition. Okay. If you see India's condition, in India, still we are importing about 80% oil and gas from outside country. So outside country, which are countries? Middle East is there, small portion US, Russia. Now you may have seen the news because of geopolitical issues. So India was buying Russian oil and some conflict coming up. Then India is buying from Iran also, Middle East, US, many. So normally what happens? One country does not buy from only, let's say India don't buy from only one country. So because what happens, let's say you buy from some XYZ country, and if there is any political and other disturbances, then your supply will be stopped. So what they do, they'll be buying from multiple countries, small portion, so that if one country is getting disturbed, you will have other source to maintain your energy balance inside your country. And if severe story problems are there in India or outside India, and you are not getting oil from outside, then what happens? In that case, India and many developed countries, they maintain reserve, strategic reserve, they say. Strategic means they will be putting oil in some underground location, and whenever required, they will take oil from there. So basically, initially they'll be using for military and security purpose. Then if still excess oil is there, then public will get, because those are more important than public, because you have to first secure your country, then other will get. Okay. And India is having about 20% oil and gas on reserve. So those are basically Bombay High, Assam, Rajasthan, Tamil Nadu, some discrete areas are there. But this is not sufficient. You can see India's economic growth is happening continuously, and because of that, power consumption increasing. Because I already told that power consumption is linked to your national development. So power consumption increasing means country is developing, but your production is not improving. So you are getting one gap. Okay, so import increasing. So how to avoid that import in that delta, whatever increasing delta you are getting, or difference you are getting. So you have to go for non-hydrocarbon based fuels. Hydrocarbon means oil and gas or coal. So non-hydrocarbon means renewable or non-renewable sources. Okay. So how to get that one, that we'll discuss. Now we have renewable energy. I already told solar, biomass, wind, hydro, geothermal, marine. So geothermal energy, India, few places are there, but Iceland and some other country they are using hugely, because Earth inside temperature is very high, and if you can drill it, that hot temperature and surface Earth surface temperature will be like 30 degree around in Chennai or India. So if you have 100 degrees centigrade Earth under surface, the temperature as Earth surface temperature 30 degrees, so temperature difference will be about 70 degree, right? So in 70 degree temperature, actually you can run your thermal power plant. So using that power plant, you can generate electricity. So that can be good for your country. So many places, hot water or hot gas will be coming out from Earth's crust. So that also people are trying to capture, so that we can get some energy from that supply. Again, one renewable energy cannot give all your energy for energy required for your country. So in that case, what do? You do mix. You can create basket. So in baskets, you can have solar, biomass, wind, geothermal, marine. All the energy will be in basket, and you can say 5% solar, 10% biomass, something like that. Then you can give to your country. So you can reduce electricity production from oil, gas, coal. Okay, oil, gas, coal. All countries they are trying to reduce, but it's very difficult because we have hugely dependency on oil and gas and coal. Because our cars and vehicles and so many things are running because of oil and gas. And next 30, 50 years also, oil and gas will be dominating in the market. It's still renewable energy expensive than oil and gas. And government is subsidizing actually. That's why your renewable energy technologies are moving up. Okay. And my research topic is marine energy. I'll discuss. So renewable energy are target one. So this is a little bit older information. So 2019 updated information will be install capacity will be more. Okay, so we have solar, wind, biomass, small hydro, everything in list, but marine energy not in the list, and they have reason. Okay, so let's see marine energy. Okay, world population increasing. Okay, 8 billion about, and it will be 9.7 billion by 2050. So number of people increasing, and your food and land these are fixed, right? And your energy, if you want to put solar panel everywhere, so you need oxygen, you need food, so you cannot put solar panel everywhere, right? And you wind also this has their limitation, and you are saying you will not be using coal and hydrocarbon. So and you European Union, can you switch up your mic please? Okay. So European Union, they plan to use 10% of energy from marine resources. So marine resource does not mean wave energy, tidal energy, maybe all type of marine energy mix. Ocean covers about 70% of Earth's surface. And actually, uh, ocean is giving your oxygen, actually. More than 70% oxygen you are getting from ocean, because ocean is having lots of algae. So they are producing oxygen. Okay. So you are dependent on ocean. 70% Earth's surface also covered by ocean. So your rain, your life, everything is actually ocean controlling. If ocean is not there, you see there will be no rain. You're not getting oxygen, and your transportation, your food, so many things will not be done. So survival of living being may be difficult on the earth if ocean is not there, or if we are not maintaining ocean properly. For example, if you are polluting ocean, so then there will be a problem. Okay, India is having 7,500 kilometer coastline. No, uh, Ministry of Earth Sciences, they have recalculated this one about 11,000 kilometer coastline. So because very small towns and other small islands they have calculated, and the coastline length has become 11,000 kilometer. Only wave energy can itself give energy needed in the world. So future can be green, right? So India importing 70%, 75% or 80% oil. So it is huge amount of money we are giving to other countries. How can you reduce this 75 huge money? Because that money amount also, whatever money we are paying per day to other countries, that will be like small countries per year GDP, the same amount it will be. So huge amount because India is a large country, so per day consumption is huge. So we are giving lots of money to other countries. And if we reduce the oil dependency, also our geopolitical situation will be better than other countries, most probably. So we have to focus on renewable energy, and not only solar and wind. We have to focus on other type of energy also. So why ocean? Ocean is the largest solar collector. Why? So ocean will be storing solar energy. Okay, daytime they will be getting sunlight, and somewhere. Can you mute, please? Okay. Uh, so somewhere solar energy falling on the ocean surface, somewhere it is night. So night means temperature is low, and solar energy falling on Earth's ocean surface, the temperature will be higher. So one place high temperature, one place low. High temperature means your air will be getting expanded and air will be moving up. Then that area will be creating some small vacuum or low pressure zone. So then high pressure zone or lower temperature area air, they will be trying to rush towards that high temperature area. So it will be wind blow will be created. So wind blow is created. That means it will give you wind energy, right? So another way it will give energy, like when air is blowing over the ocean surface, what happens? Small ripple will be created. So if you see any pond nearby your house, so when air wind is blowing over the pond, So there'll be small ripples will be there. Okay. So small ripples, if you see, uh, and in the ocean, so and long distance, say 100 kilometer, that ripples are getting there, and wind is blowing. So that small ripples will be going up gradually. When they are going up, they will create waves. So big waves are because actually it is coming from small ripples, and ripples are getting from wind, and wind is generated because of temperature difference, and temperature difference is created because of solar energy. So all the energy actually are getting from solar energy, right? Wind energy also solar energy. Your solar energy directly solar energy, and my wave energy, whatever research I'm doing, that is also actually solar energy. Okay, so solar energy to ocean, temperature difference creating wind blow, then ocean ripples to larger ocean waves. Then I'm trying to capture that wave. So wave is actually concentrated form of solar energy. Okay. uh, so ocean will have salinity gradient. Salinity means ocean water will have salinity about 35,000 ppm. Our drinking water parts per million, that salt concentration. Our drinking water salt concentration will be 500 to 1000 within that range. Okay. So if you reduce salinity 35,000 to 500, 700, then you can drink. Then we need to develop technology for that. So we are also trying in IIT Madras and in IoT Institute of Ocean Technology also trying to desalinate seawater from renewable energy sources like ocean thermal energy, ocean wave energy. Okay. So, so again, salinity means river salinity, water salinity will be low ppm, but seawater salinity higher. So in between, if you put one membrane, the river water and sea water, then one side high density water and low density water. So you create one osmosis plane. So within osmosis plane, the water level will go up. So take that water and pass through one turbine. Then your turbine will be running. You will get energy. Okay. So that salinity gradient will give you energy actually. So in India, not much research has been done. Some small level trial people have done, but still people should do, and they should try, and you can see how much energy you can get. And thermal gradient. Thermal gradient means from ocean we can get thermal gradient energy also. What is the thermal gradient? So you may have studied in your school books, 7th, 8th, like ocean seabed temperature about 4 degree 10 centigrade. Yeah, 4 degree centigrade. Yeah. So because water molecule will have higher density at 4 degrees centigrade, and higher density fluid, low density altogether, and let's say sunlight falling on ocean surface, so particle will get expanded and they'll be coming on the surface, and cold water particle will be sitting at the bottom. So sea nearby seabed temperature will be maintained 4 degree because high density fluids are there or water is there, and low density water will be on the surface. Now let's say Chennai area, southern India, water surface area, temperature will be about 30 degree, and seabed temperature 4 degree. Okay, high density fluid. So temperature difference now I have 26 degree. So this 26-degree temperature, if you have, now you see your thermal power plant, NTPC thermal power plant, Brayton cycle, right? Rankine cycle. So if you can run a Rankine cycle using the temperature difference, then you can get actually energy. Like you can, in that case, what happens? Like you have lower surface temperature, lower seabed temperature, higher surface temperature. So in that case, what happens? Uh, you ammonia cycle, ammonia you run, you pass through this loop instead of water. So ammonia will be evaporated on the surface, pass through turbine. After turbine, you take that ammonia to lower nearby seabed. It will be liquid. Again, you pass the ammonia through this hot area. It will be expanding. Again, you pass through turbine. So that cycle will go on like Rankine cycle. The NTPC, National Thermal Power Corporation, they will be running their turbines like that. Okay, they call Rankine cycle. And tidal turbine. So tidal turbine, like the solar and lunar effect will be giving rise and fall of water in the ocean. So when water level is rising, so some coastal area will be getting flooded, right? Low-lying areas. Now we create one dam, store the water. When water level will be going down, so that time that water should be passing through turbine. So when it is passing through turbine will be rotating with energy. Again, when water will be going up, it will be flooding again the coastal area. So that time again it will passing through turbine. So the same turbine can give again power. So both side the bidirectional turbine you can put there and you can get lots of energy, tidal energy. Okay. Sea current. And because of ocean tidal effect, so ocean water will be flowing inside ocean. So that ocean, like wind also blowing, right, on the ocean surface or land also. So wind blowing, so you are putting ocean wind turbine. So in that case, in ocean seabed also, you put marine current turbine. So when water is flowing, your turbine will be rotating. So that way you can get energy. And ocean wave energy, I already explained how to get energy. So number of ocean energy concepts, hundreds of concepts are there. Ocean, especially wave energy. Okay, ocean energy potential, present electricity production, whatever. Okay, so huge amount of ocean energy is there, but we don't have such technology developed. So all the youngsters should think how to make ocean useful for us, useful for mankind. Okay, now lots of energy is there. Then why you don't see marine energy systems all around the coastline? The India is having 11,000 kilometer coastline, but you don't see any wave energy converter or tidal energy converter, right? So what are the issues? Why there is no such device? Is there any commercial marine energy systems? Yes, marine energy systems are there. Like say tidal turbine. France has developed fast tidal turbine system. I think more than 50 years they're running. 250 megawatt. And South Korea, Siwa Lake, nearby Seoul, the capital, they installed one tidal turbine system, 256 megawatt turbine system for tidal turbine. Wind turbine already there, you have seen. Like if you see European wind turbine, ocean, you can see the pictures, very nice pictures. Can you give some examples of successful marine energy systems? Okay, marine energy system like tidal energy systems, marine. Okay, now, marine energy, I already discussed wave energy, current, thermal, tidal, right? One is the salinity gradient. I have not written here because technology is not mature in India. So presently, I'm working on tidal energy and wave energy, the thermal energy or that NTPC that I told, that one. National Institute of Ocean Technology Chennai, NIOT, they have developed laboratory and they are giving uh, purified water or low salt or drinking water to Lakshadweep people. How? They are getting electricity. That electricity will be used to produce desalinated water or low pressure water also they can create. So using that thermal energy in the ocean, they are using drinking water and they're giving to the people. So Lakshadweep, they are discrete islands. 36 islands are there in the Indian Ocean, west coast of India, and they are our people, and they face difficulty of electricity because they're discrete, so you cannot give grid connected electricity. The power coming to your house is grid connected, right? Somewhere it is getting produced, but through where it is coming to your home, but you cannot give that power to your discrete islands, Andaman, Lakshadweep, small islands, because the cost will be huge. Because underwater electricity cable you have to put, and there'll be sea ships going also with cargo vessels. So you cannot put cable everywhere, and you have to follow certain international protocol, and that will be expensive and difficult process. So in that case, what they do, they'll be using diesel power plant, generator set, and somewhere they are trying to put solar panel also, but islandic people they don't like solar panel because they are already green. So solar panel you are putting means you have to cut trees. They don't like. So wind turbine you can give, but still wind sometimes not sufficient. Oil and gas issue like pollution. So diesel also people are not liking. So you have one choice: marine energy. Whether marine energy can be useful for them for to make their life better because they are our people. So and in the discrete island, so we have to give power. It is our responsibility. And government side also they're trying, but still technology is not mature, so we are unable to give. So we have to try all together to give them power. Okay, the population will be about 36,000 or I think less than 1 lakhs. And on the Manipur also there. So small discrete island, we can give power from marine energy sources. And my main topic is ocean wave energy. So there are lots of technologies available. I told you more than 100 ideas are there. So you should have many ideas. Then few ideas will be applicable for practical field, right? I already told. So many ideas. One idea, the oscillating water column. I have marked the bottom one, oscillating water column. So that actually National Institute of Ocean Technology and IIT Madras developed. IIT Madras means I was not involved when it was developed because it was developed in 1980s. That time I was in school student. And that time, some professor thought India is having lots of coastal area, so we can develop ocean energy system. So they started doing work on ocean wave energy, oscillating water column. Then National Institute of Ocean Technology formed from IIT Madras or from our department, and all the technologies went to NIOT. So still we work with them, but technology and everything they have a now separate identity for NIOT. Okay. So and other technologies such as point observer, I am developing that one. If you search Google Abdus some of the wave energy converter, actually you will get point observer. So that one I am developing now because oscillating water column is NIT developing, so I am developing point of separate technology. And many other technology available, attenuator, oscillating surge converter, overtopping device, alternative wave sync, but we are not doing working on all the topics because if we want to work on all the way, nothing can be done. So just my
Okay, okay.
personal opinion is
Here we have last performance. Nishu.
so take one technology and develop it. And when you are developing one technology, you will have lots of success failure and lots of challenges will be there. If you can develop one technology, you will be successful person. But if you want to develop everything, so nothing will be developed. Finally, you will get frustrated. So take one technology, develop it properly, done. Okay. Now I'll see wave energy thing. Okay, the statistics. Okay, we have lots of wave energy. Wave and tidal energy. You can see the statistics. It is 2006 report. We have seen. Okay, huge amount of energy is there. And this picture, our department, some professors developed for Ministry of Renewable Energy. So where you can get wave energy. Wave energy, the red areas, in southern part, western part, we have larger amount of energy stored. But eastern part, Kolkata and Bangladesh, Tripura, that area, very low amount of energy is there. But if you go to Kanyakumari, Kerala area, western part, Karnataka, so you have lots of energy you can harness. Coast, we have some energy, but not as much as western coast. So eastern coast normally wave height will be half meter to 1 meter maximum. Western coast will be like 2.5 meter also. And our wave energy, how much energy is there in a wave, we can calculate based on wave height. Okay, if wave height is more, then we can get more energy. And in India, 40-50 gigawatt power can be harnessed if we have proper technology. So that will be huge amount actually, 13-40% of countries requirement. Presently, we don't have such technology, mature technology. Okay. So how surfing works wave basin? Okay. Okay. So wave, you can see this wave height, how they measure. Like say, if you say black line, who's talking, please, can you mute? Okay. So if you see the wave, it is coming like this, and this wave height is upper peak to lower peak, crest, okay, and peak. This distance is called wave height, and wave period, wavelength is Uh, this one wavelength, okay. So wavelength and wave height, if I know, I can calculate actually wave energy, how much is there. So if calm ocean is there, so then that case wave energy harnessing will not be logical. For example, you have one pond and you have some small ripples. So in that case, we do not design in a wave energy converter because that will not give sufficient energy and our invested money or effort will not be fruitful. But while if we have higher wave height, let's say Indian west coast or east coast also, some area half meter to 2.5 meter, in that case we can have sufficient amount of energy. But if you go to Scotland, they will have 5-6 meter wave height, 5-6 meter wave height. So in that case, huge amount of wave energy you can harness. Okay, just wait. So a type of wave energy converter you can see here. Okay, previous things coming up, the lines. I have to remove the lines. I have to go there. I have to erase the lines, right? Delete. How to remove this? Okay, now I can do it. Just please wait. I will remove this line so it's creating problem. Okay, close. Now you can see this types of wave energy converter left side: Western wave energy, air chamber, Wells turbine, DFIG, power electrons. So one order we see oscillating water from wave energy converter will have air chamber, Wells turbine will be there. Then your electronic system, electrical system. Then you are sending to grid or you are using the power. Okay, so some other type of technology also has similar mechanism like wave to mechanical conversion, then electrical conversion to grid or use. Okay, so now you can see here different parts of wave energy converter. Say you have wave, left side you can see picture. So from wave you are producing electricity, right side, the grid. So it can go through several channels, like first over piston accumulator channel, or air chamber channel, or accumulator hydro turbine channel, or direct mechanical drive channel, or direct electrical drive channel. So many ways you can convert that mechanical energy into electrical energy. Okay, so you have vertical wave moving up and down. You have buoy. So buoy is moving up and down. You got relative motion. So relative motion, how to convert? You have several mechanisms. You can use piston cylinder and you can pump water and you can get energy. You can put some linear generator. Linear generator will be producing direct electricity, or you can put some piston cylinder and you can pump air and it will be running turbine. So that way you can harness you can convert mechanical energy into electrical energy. Okay, when you get electrical energy, that is also you have to do lots of control and other mechanism you have to put, because that electric will be very much uneven. Because ocean wave we assume sinusoidal, but practically it's not sinusoidal. You have lots of peaks and valleys. Okay, peaks and valleys will be there, like moving up and down, and so lots of peaks and valley we cannot use for your electronic and other item. So in that case, whatever you have to smoothing the power, you have to store in battery, then you have to use, and battery requirement will be very low also. And several wave energy converter are there. You can see here Spain, UK, they have developed. And you can see India. India developed actually. This is IIT Madras started this research I already told. And in Kerala, they installed this oscillating water column wave energy converter in 1990s. Okay. The later stage in 2011, they dismantled the system. They got lots of knowledge, lots of updating they have done from this war. And after that, they divided floating type device. So initially they developed fixed type device, then later stage they developed floating type device. Okay, so I developed some turbine for them. Okay, you see this when they were developing the how big the system was. Okay, pilot plant Virinjam, this Kerala one location. So at that location, so many people they developed the system. Okay, and wafer calculation, if you see power J, it is having H and T formula. H means wave height, T means time period. So if H is increasing or T increasing, you will get more power actually. Okay, first equation. And let's say oscillating water column. I said like NIOT, they developed oscillating water column and they installed in Kerala coast. So what is that? You can see the first video. In video, you can see the water level going moving up and down. Okay, you see this properly. It's water level moving up, and air is going out through certain channel. You can see this air is getting sucked, like breathing is happening. Like this is channel and wave is coming, water level going up and down, and this is breathing. And breathing space, they have one specific design turbine. So turbine will be rotating. Okay, you see this sketch picture, water, air, and air turbine. So when wave will be entering into this air chamber, so air chamber volume will be reduced, and that because of high pressure, air will be pushed out through the turbine. Turbine will be rotating. Again, when water will be going down, again air will be sucked, and again your turbine will be rotating. So both direction turbine is rotating, and that way you are harnessing energy. Turbine rotating means it is connected to generator. Generator is giving power. So type of OWC. So I already wrote there is fixed type, floating type, many other type also many people have designed. So basically two type, fixed type and floating type. Okay. So now I said like wave energy converter is having turbine. So again, there are different types of turbine. So let's say ocean energy when I'm saying, so it is having basically four type, wave, tide, current, ocean thermal energy, and one more is the salinity gradient. Now, among these five, I took wave energy. Now, wave energy having different types, like water column, point absorber, many other types. Now, I described all the type except OWC or oscillating water column. Now, oscillating water column, when you are designing, you have fixed type, floating type. Let's say take fixed type. A fixed type when you're designing, you have one fixed structure. Okay. Now, air, water moving up and down inside structure, air, whatever accumulated air is there, air will be passing and it will be creating breathing. So in breathing, you have to put turbine. Now, turbine, we have several types. So basically two types, reaction type, impulse turbine. So reaction type is having several variations, guide vane, without guide vane, pitch control, non-pitch control, biplane, single plane, control rotary. So many types. Impulse type also axial flow, radial, cross flow, many types. So all type you cannot do research, but in IoT actually they did several turbines designed and tested in their system. Okay. So I also did several turbine research on air turbine. Okay. Now, how much energy you get? Let's say in wave, if you have 100-watt power, so finally when it is reaching to you, electricity, converting to electricity and storing battery, it will be about 10, maximum 20%. Getting 20, more than 20% is very much challenging. So on an average, you are getting 10%, I'll be happy. Okay. And then 20%, what is the benefit? It is free. Once you set initial wave energy converter, you get 10-15%, and you're getting free input and you're getting like output. So fine. Right. You don't have to pay for fuel every time. So large ocean is giving free energy. Okay. So but issue is that you have to improve performance of every system, then you get more power. For example, air turbine, whatever you have designed, it is having 30%, 30-40% efficiency. Chamber also having some efficiency, generator also having some efficiency, power conditioning. So all there will be losses everywhere. So how to minimize the losses? That is also a big challenge. So now up to this level, conclusion is the energy potential is there in ocean. Some technology already developed, but low power output, uncertainty issue is there. So several other challenges are there when you are developing ocean energy. Because the ocean is very much harsh. If there is any cyclone, tsunami is there, whatever technology developed in one day it will go, right? So you have to develop a reliable reverse system, robust system, so that you can get power for longer periods. System should not get washed away or broken because of cyclone, tsunami, water load, right? Uh, so there are lots of challenges. Now, turbine. Okay, now you see, you remember marine energy to different type, then wave energy different type. I took OWC having different type, and took fixed type. Fixed type is having different types of turbine. I took Wells turbine. Okay, Wells turbine means one reaction turbine. You can see two dots are coming up and down. The dots are actually, I am assuming this is air. So when my system will be running, air will be moving like this. And turbine is in the center, turbine will be rotating in one direction. Which is the red one direction shown here. Uh,
No, sir, SI or SI.
Okay, so this turbine will be rotating in one direction, this direction. Okay, continuously, and it is symmetric airfoil. So whether airflow is going from bottom to up or up to bottom does not matter. Turbine rotation will be unique, one direction. So that's why we call bidirectional flow turbine. But turbine rotation is unique. Turbine, like it is simply breathing. Like your nose is breathing, and in front of nose you put the turbine and turbine rotating. Okay, both direction. Inhaling also rotating, exhaling also rotating, but rotation direction is unique. Clockwise or anti-clockwise in one direction only. Okay. So bidirectional turbine we use harsh oceanic condition, and we don't want lots of mechanical element there because uh, more mechanical element, more moving element means more failure probability. So if we have only one turbine connected to generator, reliability will be more, but efficiency will be lower. So we have to see how to improve the efficiency. Okay. So now turbine. You got one turbine. Turbine is several parameters, tip groove, aspect ratio, this. So we have done lots of research on this one. We try to increase efficiency. Another issue is that for turbine, you say I have velocity profile like this. You can see this one velocity profile, right? Velocity acceleration. But what happens when you are getting power? So it is symmetric airfoil, right? Symmetric airfoil. So initially low velocity, so your power production is low. Now velocity increasing, air velocity, power production increasing, but after certain time, flow separation will be there. So a turbine blade, if there is flow separation, there will be lift drop. So suddenly we found lift drop. It's the bottom picture. My student has drawn reverse way. So that bottom picture, lots of noise is there. So that time actually flow separation happened. That time we are not getting any power actually because of flow separation. Again, when velocity reduced a little bit, again flow attached, again we get power. So initially low velocity, low power, then velocity increasing, power increasing, but velocity crossing certain level, then we are getting lots of noise and no power. Again, velocity increasing, velocity reducing, we are getting much power. Okay, so that way the turbine works. So if someone is saying like say they're getting 30-40% using this wave energy converter OWC, actually they may not have calculated or they may not have tested this one. We have tested, so we got all these results. So this is a numerical result, but we have tested also. Okay, so experiments. This picture. This is actual wave energy converter, 2 meter diameter wave energy system that NIOT's wave energy converter. It was given to IIT Madras, so it was there in IIT Madras. Okay, so diameter 2 meter. It was tested. Let's see. This is actual wave energy converter. Okay, so now I'll tell my story. I joined 2010. So after that, my background was turbine simulation, turbo machine, gas turbine blade simulation. So when I joined IT Madras, then I found that NIOT working with the turbine looks like very weak design. So I asked NIOT or Ministry of Power Sciences that your turbine is having some problem. Can I modify the turbine or redesign turbine? So then I got project to optimize the turbine system. Then I designed this one for them. Okay. Then I got laboratory system also. Then this is actually laboratory. You can see this reciprocating system rotating. So using this one, I tested the turbines. This is piston cylinder arrangement. This is mimicking the wave actually. So instead of going to ocean directly, I'll be putting turbine here. So this blue part, my turbine is here. So turbine is getting reciprocating airflow forward, backward, and they're rotating. It is connected to one electrical generator, then my controller, everything all together, everything we set before going to ocean. We'll test here. Then after that, if things are okay, then we'll go to ocean. Okay, these are individual component. You can see it is there in my laboratory. Okay. Uh, then after that, we did lots of research on turbine, different types of turbine. You can see one symmetric blade wells turbine. So initially designed, but it got broken actually. You can see this one because this is simple software 3D printing material. So we were broken again, redesigned. So several times design failure and redesign I have done for turbine. And turbine performance also student has done. Okay. Inhalation and exhalation, how the performance is varying during inhalation, one direction flow and reverse direction flow, how things performance is going on. So they have done. Okay. Now flow rectification, the actual topic. So now you can see the turbine is rotating in one direction and we are not using any rectification valve. Okay. So what is happening? Turbine flow is moving one direction, turbine rotating one direction, again flow rotating another flow going to another direction, turbine to the same direction. So in that case, lots of losses happening. So in that case, we thought let's put some rectification, flow rectification valve. So actually NIOT use that valve. So we try to design, optimize the valve. Okay. So uh, you can see this first one. When in acceleration opening, these two valve open. Where is not this one? Okay. So when acceleration opening, two valve open. When inhalation opening, these two valve open. And others should be closed actually. Okay. That way you can get one direction flow. So fluidic diode concept. So when you talk about diode, one direction flow will be allowed, another direction flow. So diode in electrical concept. In electrical concept, you have seen diode means one direction flow they will allow, opposite direction flow they will not allow. ion flow or electron flow. So in this case, we use fluid particle to flow in one direction, not in another direction. Okay. So we have studied different types of design. What about design available for different applications? Okay, you can see different application flow. For example, this one, this direction flow will be difficult, but this direction flow will be easier because particle can move directly this way. But when this direction flow, left to right, fluid is coming, so it will get hit here, it will be getting lots of turbulence. Again, going down directly, it will go here, again, it will go here. So lots of restriction, resistance they will get. So fluid will not pass so easily through this one, left to right. But right to left, if you see, fluid can pass directly here. Okay. When they're passing directly here, they will get less resistance, so that will be better. So we use this flow rectification system in a Wells turbine or impulse turbine system in a OWC, oscillating water column. Here also you can see this one, Prasad et al. Here, left to right flow. Left to right flow, it will fluid will get hit here, and fluid will not get path to exit actually. Okay, so they'll fit lots of different. So if someone is exiting, again there'll be again resistance. So many resistance they will get. But if you see opposite, left to right, from here particle is coming, they can go like this smoothly. So one directional airflow will be allowed, opposite direction may not be allowed. Okay. So here the same technology they're using. Uh, if air is going, it will go to one way. When it is coming, it will come from another way. Okay, so two turbines using diode. So one direction flow will be through one turbine, another direction flow will be through another turbine. So you get two turbine generator system, and you get energy from both inhalation one turbine, exhalation another turbine. So there will be power. Okay, so then we optimize the system using surrogate modeling. So I'll not show all the surrogate modeling system. So analytical result, if you see case one, several cases we design and found ETA. One case ETA got more than 40% efficiency. So these are CFD analysis. So when you do CFD analysis, first, normally we use ANSYS, commercial code, uh, research version we have. So in ANSYS, what we do? We do initial geometry design. After geometry design, we go for CFD validation. Then we do optimization. So I have AI-based tool. So using I wrote code actually during my PhD. So that code I'm using. So AI-based code I use and I simulate. So Hitesh, one of my PhD student, he's now in Japan. He's doing postdoc. He did all these works of flow rectification. So he did all this AI-based simulation. Okay, he has one paper also, AI-based diode optimization. So here, after CFD analysis, you can see the fluid physics. A fluid when going to left to right, top figure, you can see how smooth it is coming. Although vorticity is getting created, but it's opposite way if you think flow direction, left to right, right to left here. Here you can see fluid is getting lots of restriction here, lots of restriction here. So they'll have very difficult to flow left to right, but right, this is right to left. Left to right, it will be easy to flow. Okay. So similarly, you can see this right side picture, pressure distribution also, how pressure is increasing in flow direction when it is right to left. Right, red means higher pressure. The pressure is increasing because fluid is unable to flow. But while flow direction left to right, fluid is easily passing, so pressure is not increasing. Okay. Here one animation picture also how fluid is doing acceleration. I think image. Okay, we cannot turn because we can video is there but not visible. So this is actually a unsteady simulation. So how fluid particle are moving and how the vortex is getting created. So it's a nice picture actually. Uh, how vorticity is getting created because of flow direction changing. And I we have done several works on ocean wave energy converter. United States, one Department of Energy, they conducted one wave energy competition. So we took part. Hawaii University, Uppsala University of Hawaii University US, Uppsala University of Sweden, IIT Madras. We together we applied for one competition. Nalu AY our team name, and we got two awards for our wave energy based desalination system design. And another system, NIoT system, this one, National Institute of Ocean Technology, they designed for navigational system. And there you can see one blue section is there over this buoy in the ocean. So blue section actually our turbine in the ocean. So whatever turbine we designed, they tested in the ocean. Okay. And here lots of media also published our work. Some Bengali, Hindi, English, all newspaper, Doordarshan. So yeah, we have done a very good job, and we are doing one work on point of the wave energy converter. So we have some fund from DRDO and DST. So we are developing a large wave energy converter. We hope in next 1 year we'll be going to ocean. Thank you very much. So yeah, so audience can ask question or comment, please. Audience, are you there?
Yes, sir.
Yeah,
Thank
you
you,
can ask
sir.
question if you.
Thank you,
Mhm.
sir, for this enlightening session. We came to know we came to know about why we need marine energy, what is wave energy, different types of wave converter, and about oscillating water column. He has also shown his experimental setup and with different experimental videos, results, and animation. Thank you, sir, for this very informative session. Now I ask participants if they want to ask any question, they have any query, they can clear their doubts.
You can write also if they like. Someone has written also. It's like not there. Okay.
Okay, if there is no question, we extend our sincere thanks to Professor Abdus Samad for his enlightening lecture on harnessing ocean wave energy flow rectifier. His vast professional experience and deep insight had added immense value to today's session. With this, we come to close our session 6 and successfully conclude the third day of faculty development program. On behalf of the organizing committee, I extend our sincere thanks to today's distinguished experts for their enriching lectures, to all the participants for their active engagement, and to our dignitaries for their continuous guidance and encouragement. We look forward to welcoming you all for tomorrow's lecture, fourth day of this FDP, which promises yet another set of insightful and thought-provoking sessions. Thank you, sir. Thank you all.
Thank you. Thank you very much.
Thank
Bye.
you. Now, sir, we can
Thank you.
conclude the session.
Yeah.
Good
Thank you.
night, sir. Good night.
Good night.